Whoops. All right, can folks hear me?
Yes.
Okay, great. Well, Happy New Year, everybody.
Happy New Year.
Let's see. I know that we have one thing on the agenda today. Let me just pull it up. I hope you all had a restful and joyous end of year celebration. Also hope everyone had a very safe end of 2021. All right, Sanjeev, I see that you're here and you have the exclusive agenda item today. So we'll give it probably another 2 minutes for folks to join, and then we can go ahead and you can take it from there. And if you want to screen share and show your document that you've linked to from the agenda, I enabled screen sharing, so you can do that whenever you're ready.
Sounds good. Should we wait a minute and then start?
Yeah. Yep. Let's just wait a minute. So we'll wait till 3 after.
Paul, did you have a amazing start to 2022 since you wished us all the same?
Yeah, it was pretty good. I had a nice time. I took a couple weeks off of work.
Perfect.
Played a bunch of video games.
Nice.
Yeah. How about you, Laura?
Yeah, what happened? I did like a big, like, you know, blowout, cook the whole dinner thing. So that was fun. And my new winter thing is I got into, this is like not that interesting, but I got into candles, like candlestick candles, because you know, it just gives the good seasonal vibe. So I just stared at candles for some of it, and that was very calming. So I like
Nice.
that.
All right, well, we're 3 after. Sanjeev, why don't you go ahead with the agenda item around multi-cluster network policy. Go ahead.
Sure. So I guess I should have prepared a few slides. Would have been easier to communicate than the doc. Just curious, did anybody, I know Andrew did, but did anybody else get a chance to read the doc before the meeting?
Yes.
Okay. Thanks, Laura. Maybe we can just hear what any feedback you have. Your thoughts and comments. I'll go into detail for the other folks, but any quick thoughts from your side?
Quick thoughts. I mean, I think there were listed in the questions some like open items, like whether this needs to be implemented at the MCS API layer that I think we should all probably talk about.
Right. So you agree with some of the open questions that we've listed here?
Yes. Basically, I do think we should talk about several of those open questions.
Okay. Andrew, any quick thoughts from your side? I know you reviewed and had a few comments.
Sure. Yeah. Hey, everyone. My name's Andrew Stoikis. I work at Red Hat. I haven't been here before. Pretty active over in SIG Network, but I'm starting to work on Submariner and some other multi-cluster related things. Most of my work prior to this has been involved with network policy. So wanted to come here and hear Sanjeev out. I think, you know, after a first review of the document, the main question for me is, well, main questions, I guess, are, do we need a new resource? And if we do, how tightly is it going to be coupled specifically with the MCS API? So that's a little bit of an overlap with what we were already talking about. But aside from that, I think it's still super infantry stages. And I'm excited to hear what you guys over here, what everyone over here thinks about such an object.
Okay, sounds good. Thanks, Andrew. So yeah, that's also an open question. So as Paul suggested, we'll just go over the main points and we can kind of have an open discussion. So this is about, some early thoughts around what could be an API or possibly a modification of an existing API, but all related to multi-cluster network policy at the quote unquote service layer. And that's why the thought was to initially assume that the network satisfies the MCS API, the multi-cluster services API. And so the assumption is you have any implementation of an MCS API, but you also want to do some kind of policy filters. What could you do, right? So these are some early thoughts. I fully expect that based on feedback from both the SIG as well as SIG network and SIG network policy, we could evolve this. So I've kept a lot of things as, initial drafts, but subject to change based on community preferences. So that's the basic thing, okay? Like I said here, it focuses on policies for environments that implement the MCS API. That's the only assumption made. And the goal is then to eventually translate that potentially into KEPs. Eventually, this will cover both namespace scoped policies as well as cluster scope policies. But for the first iteration, just focusing on namespace scope policies. And the goal is not necessarily to look at policy that applies to specific implementations of the MCS API, examples of which are like the Submariner project and some of the public cloud controllers for MCS API. So as you may have noticed, those who have read it, I have purposely kept a lot of open questions because open to however this goes, right? And understand objectively where it makes sense, where it doesn't make sense, or where it, it could be done differently. So the very first question is, let's be clear that, do we really need a multi-cluster network policy? Or should we assume that there will always be some another service networking layer on top, maybe a service mesh, where we can choose to, or maybe even prefer to impose policy? So that right now the working assumption is that there may or may not be a service mesh on top of the MCS implementation. And just like regular network policy is needed, regardless of whether there's also a service mesh running on top of regular network policy, similarly, you would need a regular multi-cluster network policy, regardless of whether there is a service mesh or not. But again, this is inviting candid feedback on understanding what are the deployment patterns and where people want to have policies. The other one is, okay. So the network model assumed here.
To your first question, I kind of want to add another question in there. Do we need a network policy, or will there always be a layer on top? I think is a good question. But another question, assuming there's no layer on top, and we want to have a Kubernetes native network policy, do we need a new resource anyway? Because like we already have network policy, right? And I know that that's evolving. Do we actually expect that cross cluster needs to be fundamentally different than in cluster? If I'm, if I only want services in one namespace to talk to a specific other namespace, and I want to lock everything else down, or I want to, have only certain pods can talk to this service, does that actually need to change across clusters? Have we changed the concepts? I mean, aside from smoothing some of the gaps where you have to talk about, selectors instead of services for a network policy. But if, is there a fundamental difference, I think is the question that I have.
Agreed. So we do have similar open questions as we go into the doc. And like you said, even if there is a service mesh on top, which has its own policy layer, you could still need a multi-cluster network policy, just like you need regular network policy, either because different personas prefer enforcing policy at different layers, or because the policy can be made independent of specific types of service meshes, right? So yes, the working assumption is this, but agree with your point, and those are in fact some open questions I have in this doc. So definitely open to, the community talking about requirements and expected deployment models. Now, we did discuss this a little bit within SIG network, and I've had some offline discussions with Tim Hawkin and others. They do believe that this is needed, and this kind of straddles between SIG multicluster and SIG network. So Tim was quite positive on having something started for this, but we'll keep on iterating as we go. So the network model we are assuming is that, okay, it must be a model that that supports the MCS API. So we assume the same kinds of terminologies about service imports and exports and cluster sets and namespace sameness. The other thing we are assuming for now is that we want to keep this as flexible in terms of the pod IPs. So the backend pod IPs of the services may or may not be globally unique, right? So there could be scenarios where using the MCS API, where you're assuming that all pods and services come from a single global IP space. Some other deployments might not assume that. So what we're assuming for now is that definitely we do not want to assume that pod IPs from across all clusters and certainly across all multi-cluster services come from a globally unique space. But service IPs, by the very nature, must be unique across the cluster set. So the cluster set IPs, because they are required to be reachable from other clusters, are unique across the cluster set, but the pod IP.
So that's not actually, the MCS spec doesn't actually require that. Each cluster can have its own picture of a cluster set IP, according to the spec. So, and in our implementations, I don't actually know if we have any that do have a single global cluster set IP.
Yeah, got it. You're right. I will update this on that. Let me just put a note here as we are speaking.
Yeah, it's the service names have to be consistent and unique, but not the IPs.
Yep. Sorry, maybe I shouldn't try to update dynamically because. Okay, I've just put a note myself. I'll update that. Thanks. Yeah, agreed. Yeah, so the model is basically whatever is the MCS model, and nothing more and nothing less. Now we do have a note here which says that there are some vendor implementations of some kind of network multi-cluster network policy that do make these assumptions. Like, for example, they assume that backend pod IPs are globally unique and so on. Should we do anything special keeping those restrictions in mind? At the moment, the answer is no, but if the community feels like we can have some generic policies which make no assumptions other than MCS API, and then some additional ones that maybe assume that backend pods are unique, because then you can also have policies that simply just look at IP CIDR based classification and assume that the IPs are all unique across the entire cluster set anyway. So you can just do regular network policy based on IPs and you can do everything you want. But that is not as generic, and it could have some scalability issues. So we have put a note at the end of the doc that that is a valid approach, which some projects have taken, but it seems to be somewhat restrictive in its assumptions. The other thought is whether to delegate this function to the actual implementation of the MCS API, or whether to do it at a layer that is independent of the MCS API, independent of the implementation, right? So maybe that could be another thing that the community could think about, whether, okay, yeah, this is some, if it is expected that we want to not standardize this, but let each implementation have its own flavor of policy. Okay, let the community speak up. But if the community feels that we should have policy independent of implementation, that's what we are assuming for now.
I think from like the Istio standpoint, I think, we would prefer to use Kubernetes as the building block for anything like this. So I would think we would want that kind of standardized.
Okay, thank you.
Yeah, I'd second that too. I mean, obviously, I'm very much behind the MCS API, but a big part of that is trying to make it as portable as possible so that you can use, whatever vendor or, mesh if you want to connect your multi-cluster services. And if it would be great if network policy kind of followed the same pattern. So you could just plug in different implementations and not have to change your policy.
Yeah. So those are in fact the working assumptions of this proposal, but I wanted to objectively put out the alternatives just in case somebody had a preference for another approach, because this is still very early. We can make it go wherever we want. The other one was, okay, do we necessarily need a new API, or should we just modify or enhance an existing network policy API? That is still open, and that's something which we would want to discuss within SIG network. For now, for this draft, I'm assuming it's a new API resource, but we could certainly look at it as an extension of an existing API resource as well. Okay.
Has there been any discussion in that regard to this point? Just kind of curious what the pros and cons have been so far.
I introduced this into SIG network just last week, so it's too early. We haven't actually discussed each of these points. So I'm sure we'll hear more in the coming weeks on that.
And just a little backstory that's a little relevant. The work, there's been a lot of work, I guess, for like a year now on a new object called what was cluster network policy and is now going to be called admin network policy. It's more of like a cluster scoped version of network policy. And if we wanted to implement this into that, it's definitely possible at first glance. You would just kind of add a new selector. I think a main argument against doing that and creating a new object would be if we decide this policy is going to be implemented in the MCS API implementations, right? Rather than in maybe the CNI and the MCS API implementation. So those are some things to think about, I would say.
Thanks, Andrew. I actually had that exact question. How is this tying into the ongoing effort? An effort that I have not been following, admittedly. But yeah, I think another question, though, I guess another flavor of what you kind of just mentioned. Could we have the same API, but maybe with an annotation or something if you need to, if it, if the multi-cluster implementation needs to be watching it? I definitely have some bias here. I would love if, your single cluster configuration just magically worked across clusters when you added that service export and you didn't have to like redefine anything. That would be really great. I don't know if that's actually feasible.
Agreed. I will go on to one particular point, one of the sample YAMLs where we used an analogy that I think previously when you were extending multi-cluster services to the gateway API, you chose to use the service selector, service import as a selector rather than service as a selector. So today in network policy, there is neither service as a selector nor service import as a selector. But having the keyword service as a selector allows you to have a common procedure both for single cluster services as well as multi-cluster services.
Yeah, that would be great.
Right. But partly because of both the example in the gateway API, as well as in some particular implementations like Submariner, I noticed that there is a differentiation made between single cluster services and multi-cluster services. So it's an open point for now. For this initial draft, I've said, okay, let's start with a different API with a different selector, but totally this question is basically saying, but yeah, we could modify this to an existing API with some annotations or different selectors.
That makes sense. And if we're building off roughly an API that looks as close as it can to the network policy implementation, and they end up being identical, then we can merge. Otherwise, we can have two that are at least intuitive to jump between.
Yeah, and we've been building the admin network policy API to be way more easily extensible than network policies. Like, we've built the API with the mindset that we are going to have new selectors one day. And another thing that actually might help the integration is that the admin network policy is only focusing on east-west traffic. So like, I'm trying to think, if we had built in north-south traffic management into that API, I don't know how that would work at a multi-cluster level. Like, it's a little funky. So that might actually be advantageous to just building on top of that existing API as well.
Yeah, now only the one flip side, the other thing to note is that both this proposal as well as the current MCS API are essentially namespace level objects, right? Whereas the admin network policy, as you recall, Andrew, is cluster scoped. So MCS API essentially works at a namespace level where each namespace is deciding what to export and import. It is a tool primarily for a namespace DevOps persona. So that's something we have to think about. I don't want to rat hole on that, but there are two different personas that those objects are targeting. So this may need to be something which is more aligned with a future version of the conventional network policy than the admin network policy. But we look at both those options as well.
You actually raise a really good point. Who is creating the network policy? Is the service owner deciding who can talk to this service, I mean, there's a bunch of answers to this question, but or is this targeting the platform team who wants to decide which services or which teams can talk to each other? Is it always going to be the same person? I think the answer is probably both.
Yeah. So the goal here is to potentially have a version of this that is targeted for the developer persona and a version that is targeted for the cluster admin persona. So that's what I put as sort of this assumption number 4. But the initial version of this document is targeted at a persona that is either an application developer themselves or a DevOps persona, because it is namespace scoped. And the same analogy is true for network policy as well, because when it is namespace scoped, it is targeted at the DevOps persona. When it is cluster scoped, it is targeted at the cluster admin persona. Also, as you will see, the policy expects knowledge of the application that, okay, these pods within the same namespace can talk to this imported service and these other pods cannot talk to it. So it requires that application awareness, which means it's probably an application persona or a DevOps persona. So yeah, so the goal here is to sort of follow the analogy of both the namespace network policy and the admin network policy, but extend those to multi-cluster. And the first pass of this is for the developer persona. And once we sort of have a roughly agreed upon design, then we can talk about how it is applied to both the developer persona and the admin persona. Sorry, I maybe rambled a bit there.
No, that made sense. That made a lot of sense.
Okay, so yeah.
I think we need to see how this evolves for sure, because I could see that maybe the admin persona is actually the only in the multi-cluster case, more commonly the person setting the rules, since they're also responsible for configuring the MCS implementation, and maybe the developer persona has less weight in multi-cluster, or maybe not. Yeah, but
we'll come back to that. There's some interesting points there to go over. For now, for the purpose of today's call, think of this as a developer persona working within his namespace. And since we have namespace sameness, he has access to all of those namespaces across all of those clusters, which are relevant to this application. So then we talk about sort of what are the policy types and how do they get attached both to the control plane and the data plane, right? So first, let's look at a pictorial representation of what it might look like. So here there is a Kubernetes cluster, which has got two pods running, P1 and P2, and they've got the regular CNI networking data plane, right? And typically in a multi-cluster services API implementation, there's also some kind of multi-cluster service gateway, even though the MCS API itself doesn't actually create a first-class object called MCS gateway, right? The MCS API is sort of operating at this abstract level, but the actual implementation is having a gateway. So the places where a policy could be attached could be either attached to the pods, just like regular network policy, or we could think of attachment either explicitly to an object called the MCS gateway or to an abstract multi-cluster service, which implies it is actually attached to a gateway, or we just leave it to the implementation wherever you want to attach it, as long as it functionally works, right? So in this picture, there are two pods in one cluster accessing a remote service, foo, right? So this is a remote cluster, this little box, reachable across an internet, reachable across a network. And there is a remote multi-cluster service called foo, which has two backend pods in the remote cluster. And both these pods, for now, want to be able to access this remote multi-cluster service, okay? Now, that means that, but we want to then control, maybe we want pod 1 to access the multi-cluster service, but not pod 2. And that's where some of the sample manifests kind of go into the details. So those are data plane attached policies. Now there is also potentially policies at the control plane layer, right? Which is, should this cluster even be allowed to import this service, right? Today, the model in the MCS API is the moment a cluster, the service is exported, all clusters in the cluster set automatically imported.
We actually have fitting with this, we actually have an exception for if namespaces don't exist. If the namespace for a service does not exist in an importing cluster, the spec says you don't have to import the service. So okay, that's a very coarse knob that can be used to implement the kind of behavior you're talking about, where you say, no, these clusters can't import services from this namespace.
Right, but perhaps, as you said, it's a coarse knob, right? But we don't want to control how individual clusters name their namespaces. If they coincidentally named a namespace that happens to be also one of the namespaces in the
well,
namespace.
We've actually been, like, the SIG kind of released a position statement on this. We do want to tell people, don't name your namespaces the same thing if they're not the same thing in the multi-cluster world, because it makes things very difficult. If I name something, foo in my cluster, and you name something foo in your cluster, it gets really hard to reason about what those services are. So, we can always revisit our position, but the SIG MC has kind of taken the stance that you should avoid duplication, and that's a problem. So namespaces should be unique or be referring to the same services owned by the same teams, that kind of thing. So if, I think we can feel comfortable taking that stance here. It certainly simplifies a lot of this. Yeah,
I actually agree with the thinking behind that. So let me restate it. Let's agree for now that is a reasonable assumption, and we have namespace sameness throughout. But it still doesn't change the fact that we could still want a control plane policy where you have the namespace sameness, but I still do not want to import a particular service into a particular namespace, even though that namespace is part of the global namespace set.
Yep. I agree. We should dig into that more though, and see like, does that actually make sense too, or is that like, I can see someone asking for that for sure. I could absolutely see like one of our customers asking for that, all kinds of people in the community, but I wonder if we couldn't come up with a better model that will make life easier. Maybe don't do that could be a fine response.
Correct.
We should investigate, because like, well, you might be fine with one service being imported, another not. Like maybe 2 namespaces is better anyway, because your security profile of those services is quite different, and if they're living in the same namespace, there's going to be more shared resources. Like maybe we're solving the problem at the wrong point, or not.
Yeah. So that's why I just put a note on that one for now. I didn't dive too much into it. I'm focusing on, at least this draft is focusing on the data plane attached policies, but I just put a paragraph here saying that we anticipate there could be a third class of policies which are purely control plane policies and essentially filter the imports and exports. But then we just put a note saying that we will, if the community feels we want to go there, then we will add more to it. But for now, I just put a reference and I left it at that.
Can I just see if I understood the last part of the conversation? It sounded that there's some assumption here that network policy is going to make a statement about what clusters traffic can go to, but it sounds like if namespace sameness is as strong as SIG-MC wants it to be, we would only be establishing what namespaces, we would be establishing more at the level of what namespaces traffic can cross. Did that make any sense?
Yeah, but the point was, I think, let me state a point here and you can decide whether that answers your question. Even if we assume that there's namespace sameness, right? And every clusters have exactly the same namespaces and all of that stuff, you still may not want to import into every cluster every service that was exported within that collection of namespaces. So there could be a popular service that everybody needs to access, and there could be a unpopular service that only 2 clusters in the cluster set really need to access. Or,
Right.
or it's a high security service that only privileged pods can access that particular service. But it's all within the same collection of namespaces.
Right. And I guess there's a open spot here. I think this is what Jeremy was saying of whether we want to basically say no to like making that choice at a cluster level and keep namespace sameness as strong as it has been historically.
Agreed. And
Okay,
I'm not
got it. Just catching up.
Yeah, I'm not challenging namespace sameness. I mean, we could certainly revisit that, but I'm saying even assuming namespace sameness, there still could be the need for filtering imports and exports, even while retaining namespace sameness. Yeah. Anyway, so that's, I just put a reference there, but the bulk is to focus on the data plane policies. Okay. Yeah. So I'm going to not go into the details of some of these user stories for now. Please look at it. The first few user stories are more about things like what should the default behavior be, or how should they coexist with network policies. Does the default logic of network policy also apply to this? All of that. So for now, unless somebody really wants to go into it right now, I'm going to just pass by that, so that we can just look at a couple of sample YAMLs for now. And later on, if there's interest, we can come back to these other use cases also. So let's look at one particular use case, which is in the user story number 5, right? So here, the story is that I want to be able to, in a cluster that is importing a service, I want to be able to control which pods can access that imported service. Okay. So here's a sample YAML, but let's go to the picture. Maybe that'll give a little bit more intuitive feel, and then we can come back. Where did the picture go? Maybe I deleted it accidentally. Okay, maybe we'll use this picture for now. So this picture shows that I want a policy which says pod 1 cannot access this remote service has been imported into this cluster into the namespace which both pods P1 and P2 belong. So both pods P1 and P2 are in namespace X, right? And MCS foo is in also in namespace X, but on a remote cluster. And that policy has been imported into this cluster. That service has been imported. But I still don't want every pod in that namespace to access that imported service. So that is the use case with that example tries to address, right? Because just because I've imported a service doesn't mean everybody in my namespace gets access to it. Okay, so this is sort of the pictorial view that pods P1 and P2, both are in the namespace that is importing a service, but only P2 pods get access to it, not P1. So a possible YAML for that could be something like this. For now, again, let's for now assume that it's a new API object. As we said earlier, we could talk about a modification of an existing API object also. But all it does, it looks pretty similar to an existing network policy. This one is attached to pods. So it selects a pod and it says that those pods which are labeled as clients of this multi-cluster service are allowed to egress to this imported service. And those other pods which are not legitimate clients of this imported service will not be able to egress traffic to this. And here the selector is a service import. So this is just like the gateway API has a backend reference to a service import. I kind of use the same kind of keyword there. So it's pretty simple. It looks pretty much like a regular network policy, but it defines the remote peer through a service import. Okay, so you can see that this kind of policy would meet that use case, which we saw in the picture. Any questions on this one? And also whether this use case is valuable or any thoughts?
So I have a question about this. So is this policy, the goal of the policy is to enforce the policy, or it's like it's something that, for example, because you use the labels, then anyone can add, any pod without label can decide to add this label, then suddenly it will gain access. So is that something you want to prevent, or that's not something you care about?
Yeah, so that's where partly it goes back to the persona discussion, but that's exactly how network policy works as well. So here's the thing. Imagine this is a DevOps or a application developer persona that knows his application, like which pods should connect to the service and which pods need not. They are doing this to have the least privilege kind of security model, right? They could have decided that, hey, I'm controlling this namespace, I let everybody talk to everybody. But in order to have least privilege, I only want to talk to I want only pods P2, because maybe the pods P2 are the only ones that actually really need the remote service to talk to it. And I want to block P1, even though I control both pods P1 and P2, because if pod P1 is compromised, then it will not be able to access the service. I want least privilege. I want only the pods which I know really need to access the service should be allowed to access it. So this is the same philosophy of even regular network policy, right? I mean, if I was running in a namespace, I could have just said, allow every pod to always talk to every pod. Like, why should I even bother with network policy? Because these are all my pods and I trust my pods. Well, the point is that even though these are all my pods, they can be compromised without me knowing it. So I have to have least privilege. Least privilege means only the pods that functionally need to access that service get to access it, even though the other pod is also a pod that I'm writing, but I know semantically that this pod doesn't need to access the service. So this is sort of like what they call defense in depth and least privilege, right? Does that answer your question? Sorry,
Yes, I think so. So basically, you're not trying to prevent pod from gaining access to that one if you're a pod admin, but you're preventing the code running in the pod to access that if the code has any problems.
Correct. Okay, there can be other use cases that this particular use case is for that sort of need.
Yeah, I've always thought this part of network policy is interesting because there's really kind of two audiences, right? There's the ingress policy, which you really just want to be like a service owner. I want these sets of pods to talk to this service. And then there's that egress policy. Yeah, like I want this pod to only talk to this one service because I'm worried that maybe my code is trying to reach out somewhere else or something like that. Today, they're kind of in the same API, but they have very different use cases, especially in multi-cluster. Because in multi-cluster, I might want to say that my service, like my service is only accessible to these namespaces. It actually probably seems reasonable in most cases because you relying on pod labels is not great when those pods are in other namespaces potentially owned by other teams because anybody can label a pod. But for the pod owner controlling who their pod can talk to, that kind of control makes more sense.
Yes.
Do we want to split things out more? Maybe, like maybe formally separating those. That's probably too big a question and has more to do with the future of network policy than just multi-cluster network policy. But I've kind of always thought that's interesting that we've just bundled those together.
I mean, Jeremy, from the multi-cluster API's point of view, what do you see as a more important use case? Do you see a cluster admin giving a namespace in their cluster access to an exported service as the main use case, or do you see a developer who owns a pod as allowing their pod to talk to an exported service, the use case?
I think,
like in my mind, it seems the admin one is more important.
I think that's definitely the most important in multi-cluster. I think
I think that's where we need to start.
Right. Like the pod level thing is it seems like in all cases, it's just a layer of control for the pod, multi-cluster or not. You really just want to control what ranges your pod can talk to because you don't want it reaching out, right? It's single cluster, multi-cluster, or talking to some legacy VMs. It's all kind of the same story. I think for multi-cluster services, these teams can talk to this service and these teams can't is probably the more common use case.
So, hey, name's Nick, work for Google. I joined this on a whim, but I'm very interested in this topic. I deal with a lot of customers who are doing multi-cluster or trying to and using MCS right now. One of the most common sort of implementations I see of multi-cluster services are that I have a microservice, gotta hate that term. I have a microservices app, right? Many services live in the same namespace. They come through some ingress, they hit service A. Service A has to make a downstream call to service B. Service B is dead in the cluster that they're in, and they want it to traverse to the other cluster. Right, so that's two services in the same namespace.
Right.
That's I think the canonical multi-cluster service use case, in my opinion.
Yeah. So, of course, one of the main values of the multi-cluster service API is to have backends across multiple clusters so that either that service is dead in your local cluster or it's dead in cluster A, but it's still reachable via cluster B. You want to have that availability, right?
But these companies that I work with are heavily regulated most of the time. And so they're not just going to say any service within a namespace can talk to any other service within a namespace on any port that you want. Like that's highly unlikely.
Yeah, good point. Which is you're reiterating the point that even within the same namespace, you need micro-segmentation, right? You need to exactly decide who's allowed to talk to whom, even within the same namespace. Is that
pretty much? Yeah.
Yeah. So that is what this use case is, or these thoughts are kind of addressing. And Jeremy and Andrew, to go back to your early point, and thanks, Nick, and I definitely welcome more of your feedback from what you're seeing in the field, because some of these we're making reasonable guesses, but any actual customer data that you can bring and others can bring would help us prioritize, what makes more sense to do first. So please continue to bring your, valuable customer data to these reviews or to the community. The other point here is that at least I see the MCS API as it is defined right now to largely be a developer focused API other than the cluster set. The cluster set is a admin sort of responsibility, right? He's defining which clusters get to be part of the cluster set. But the namespace API service exports and imports are more at the namespace level. So they'll do, and I'm looking at this network policy also as sort of just an augmentation of the exports and imports. And hence, in this particular form, more appropriate for the developer persona, while at the same time, a variation of this would be most appropriate for the admin persona. Let's continue that at a, we'll need to draw a few more pictures, but all those are just some thoughts in response to what Andrew and Jeremy were saying earlier. Any other feedback from anyone or any other experience with real world deployments that you would like to bring? We can talk about a few more things, but before we leave this use case, any other comments or questions?
Kind of a follow on to the last one, just with respect to isolation in general. So I could envision like a use case where I'm bringing a cluster that has same namespaces and same services that the cluster set already has, and I want to onboard it into the cluster set. But as I want to be able to do that without changing any cross-cluster load balancing behavior to start with, and then slowly opt into that. Now, if I understand the way MCS would work today, I would automatically get service imports and everything would just start talking cross-cluster. But to be more safe, you would probably want some sort of network policy kind of installed at like before you kind of join it to the cluster set that says, I don't want to change any behavior off the bat. I just want to join the cluster set, and then I can slowly kind of open up that network policy to allow services to talk between that cluster and other services in the cluster set, both egress and ingress.
Yeah, that is also related to the discussion we were having earlier about filtering which clusters are allowed to import or export which services, even though they're still part of the cluster set.
Yeah, I think that's an interesting like time window of when, like implying that there's a time when the cluster has joined the cluster set, but it doesn't really sort of have like this full trust yet. And it's still like warming up, I guess. And I can see that even more so than like otherwise arbitrarily having, I think to the earlier point, we've been trying really hard to not have users like treat their separate clusters special in a multi-cluster case and think more at the namespace level. But that time window of when a cluster is joining the cluster set, and if we want to do something special of how that cluster is treated, makes in my mind, stronger case of filtering network policy by cluster.
Yeah, there's also one, agreed with everything you said, Laura and Nathan, I think it was earlier. One other thing is, if you look at the goals of the MCS API, it is both for services whose backends are across multiple clusters, as well as services whose backends happen to be all in one cluster. In which case, it could be that in order to not all services are within the same administrative domain, and you could have services which are administered by team A to need to be exported to other services which are administered by team B. So you can be crossing a trust boundary as well, and we need to address that case, as opposed to all these services all being part of team A's responsibility. we will draw some more pictures as we go, kind of to illustrate those cases. Okay, we're going to run out of time soon, so I'll just mention one more user story. So the earlier example we said was limiting a pod to egress to a remote cluster. Now, what about the ingress side, right? So now, as it happens, a cluster which is receiving traffic from another remote cluster, in most implementations has no idea which is the originating pod, because as you recall, our starting assumption was that pod IPs are not globally unique. So you can't use the original pod IP when you're sending traffic to a remote receiver, right? So which means that the pod IP has already gotten natted. So you've lost the identity of the source by the time you get the packet on the receiving cluster. So we can't really have, naively, we can't really have any policies which differentiate between two pods of the same remote source cluster, right? So to go back to that picture, I could implement this policy if this is what I wanted to achieve. I could implement this policy either by on the sending cluster, controlling who gets to send to the service. But what about the receiving cluster? If the receiving cluster says, I want to receive traffic to this service from pods that meet this criteria, but not from pods that meet that criteria, I really don't have any way of enforcing it, because by the time the traffic comes to this cluster, I don't know whether it was sent by P1 or P2. We've lost the identity of the source because they've gone typically through a gateway, and both of these pods got source natted to the gateway's IP, right? So that's what this other use case is trying to address. Like, if we want this sort of cluster to control who gets to send to it from within the cluster set. But we know that most implementations are going to NAT out the source IP, and we are not requiring everybody to have globally unique IPs. So for starters, at least one thing we could do is to have the selector based on the cluster name itself. So this is the other example where we are saying that for pods that are actually providing the server side of MCS foo, I only want to allow traffic from this cluster. This is still not enough, because I could have a malicious pod in a good cluster. I mean, I may trust this cluster, but still there could be some pod that I don't want to receive traffic from, as opposed to another cluster in the cluster set, which I know for sure that there should be no client of the service in the cluster. So since the MCS group is also sort of have got the cluster ID and the cluster naming project going on, we know that every cluster will have a cluster name, and at least we can do some filtering just based on the cluster name as well. If we want to do something more granular in that direction, then either we have to assume that traffic will be sent with some metadata that identifies the source, right? So that even if it is source natted out, there is another tag in the packet that tells us that this came from P1 but not from P2. But since it's not clear that the MCS or this community wants to assume a particular kind of encapsulation, so for now I have left that out. But I just put a note here that if we want to make an assumption that there is some way of carrying metadata from a source cluster to a destination cluster, that metadata can then convey information from the source cluster to the destination cluster. But right now, there is no opportunity for us to convey information from the source cluster to the destination cluster. So at the most,
Yeah,
yeah.
This one's really tough. I think on the MCS side, we would definitely prefer not to have cluster level filtering. It kind of breaks the model apart. because now, basically we break namespace sameness, right? You can block a cluster that may or may not have the right namespace. Yes, you can know that it doesn't have the right namespace, but it adds another layer of things that you have to know to use the API. And it makes it easier to break. But I absolutely recognize that it is very hard to filter specific namespaces from a cluster that has or that's behind a gateway.
Right. So this is something I just put it out there. We could do some things, but we are limited. And I know that some of the SIG network guys, and Tim in particular, had some more thoughts. So we're going to be following up with them as well.
Well, one thing though on this, not answering this or even suggesting anything, but we have avoided in basically all circumstances assuming anything about implementations. I think one thing that we can rely on is that any given MCS implementation does know about all the clusters. So it can potentially act as a way to relay metadata. Not sure that helps that much in the gateway case. We need to figure that out, but other clusters, I think we can assume that other clusters are not black boxes to the MCS implementation.
Right. And this is where we had sort of one assumption in the beginning that particular implementations, if they know that every cluster in the cluster set is, the implementation is my implementation, I could add a proprietary tag in the packet whenever I send it from cluster 1 to cluster 2. And in that tag, I could have some context which can be used for filtering. Whether we should standardize or not, that's still an open question. Like you will not standardize the actual encapsulation, but you can perhaps standardize that there will always be a way to communicate 16 bits of context from source to destination, however the implementation chooses to do it. But maybe even that assumption is not valid, in which case the least common denominator is all you can know is the identities of all the clusters in the cluster set, but you cannot send context in the data plane from the source to the destination cluster. So as you can see that we've kept several things as open questions so that the community can feedback. I didn't want to be overly opinionated early. We're putting some thoughts with some possibilities, but this is all flexible to change based on the community feedback, both from this community and from SIG network. And this is a very early thing for people to think about and kind of throw darts at. There are a few other potential user stories, SIG network also. So we talked about using the service import as a selector, but what about just using service itself as a selector? Because that can then be useful even for the single cluster case. There's some pros and cons there, which we're probably going to run out of time to go into, but that's something we'll need to discuss in SIG network. There's also some thoughts on using service accounts to convey identity, still at an early stage. So, and the last thing in this doc is just a reference to some projects that have done some things with multi-cluster network policy. One example is a project called Coast Guard, which is part of the Submariner implementation of MCS API. And it is based on the assumption that all pod IPs are from a globally unique. So you can actually, when you create a network policy in one cluster, you can translate that into equivalent policies in the other cluster, which look for the unique IP of the sending source. Really, every cluster knows every remote pod's IP, or at least pods that are parts of multi-cluster services. So maybe that works in many cases. Maybe that's all that's needed, in which case maybe we don't need to do anything more. Initial feedback from Tim was that, well, we shouldn't assume that pod IPs are globally unique. That's typically not practical, but it may be okay in certain cases. So these are all thoughts which we have included so that people have a reference on other kinds of thoughts in a similar space. There are also certain CNIs like Cilium, which have their own kind of cluster mesh, which is kind of a proprietary version of MCS-like functionality without actually doing the MCS API. But since our assumption is we want to stay within the bounds of the MCS API, we can just use those as inspiration, but not for actual functionality. So anyway, sorry, we've kind of rambled on, but this was just to introduce this. Please provide your comments, and we'll be. It's pretty open right now, but we'll be evolving it over the coming weeks and possibly months.
Yeah, this is awesome. Thank you so much for coming today. Great discussion. Lots to think about. Thanks a lot.
Thank you.
All right, I think that is the meeting for today. Thanks everyone. Again, this was great. I've got some reading to do. I think I would love everybody comments on the doc.
Yeah, and hopefully we can do another touch point. I don't know what the best way is for us all to keep in sync with each other, since I know this is also being discussed in SIG Network.
Maybe the doc for now. Sanjeev, I don't know.
There's actually a SIG network policy API channel in Kubernetes. Maybe that's a good crossover point. It's not SIG network, it's not MCS, it's somewhere in the middle.
Yeah, Slack is great. Cool.
Yeah, it's SIG.
Oh, Andrew, I think we've lost you.
Yeah, is there a doc that we could just go read on that policy so far?
Well, this is, or the other network policy, because this one's linked in the meeting notes.
Yeah, the other network policy. Sounds like there are a couple.
Yeah,
in parallel.
I'll link. I guess is there an MCS? I'm sure there's an MCS Slack channel. I'll put the link to the KEP in there if that's all right.
Perfect. And once you do that, I'll copy it over to our meeting notes.
Okay, thank you. Yeah, I'm on my phone, so I can't easily do it.
Yeah, no worries. Awesome. Thank you. Thanks, everyone. I guess we'll see you in a couple of weeks and on Slack.
Thank you.
See ya. Thank you.
Thanks, everyone. Nice to meet you. Bye.